Okay, we're going to start section 7.4 today, and this is all about similar triangles. So I just want to do a little bit of a review here. Something that you should have learned in elementary school, but you might not remember, is the sum of the angles in a triangle, and that is that in a triangle, all the angles inside of a triangle have to add up to 180 degrees. So it helps out because to find an unknown angle measure, we start with 180 degrees and we can subtract the known measures. So here, okay, if we know that these two angles are exactly the same, we have 50 plus 50, which is 100. We know that all of them have to add up to 180. So we can take 180, subtract 50 more, and we know that this one here is 80 degrees. So that's just something that's going to be helpful in grade 10 as well. We do a little trigonometry work, and so having the understanding that the sum of the angles in a triangle is 180 is very important. Okay, so if we did this one now, okay, to find the measures of the equal angles, we know that all the angles have to add up to 180. So we can take 40 away from 180, which is 140. And because these are exactly the same, we can take that 140 and divide it by 2, and each of them is 70. So just something just to remember from your youth. Okay, so let's give this a whirl. If we had these two measures given and we were trying to find the unknown angle, we could take 180, subtract 60, then subtract 50 more, okay, which is 110, and we're left over with 70 degrees. So that's just one way to do it. Some people add these two together and then they subtract the 110 from 180, in whichever way you feel more comfortable. Okay, here's another example. Now remember, these symbols mean that these two angles are exactly the same. Okay, so how do we figure out angle Q? Well, we can simply go 65 plus 65, which is 130, and we can subtract that from 180, and we can figure out that that is a 50-degree angle. Okay, so how can we find the measure in this? Number 2, we know that this angle here is 70. We know that all of them have to add up to 180, so we could simply go 180 and subtract 70. Gives us 110, and then we know that both of the angles have to be exactly the same. If I had asked you for more information, you could perhaps tell me that this is an isosceles triangle. Okay, 110 divided by 2 is 55 degrees. Okay, so that's just a little bit of a start before we get into the meat of things. Okay, so now we're going to talk about similar triangles, and in similar polygons, two things had to happen. The sides had to be proportional, and the angles all had to be congruent. Matching angles had to be congruent. Similar triangles, I think, are a little bit easier because it's an or thing. Okay, matching angles are equal or the sides are proportional, because triangles are special, and if one happens, the other has to happen. So it's kind of neat. We sort of cut our workload in half. Okay. The only thing that's going to be a little bit more difficult here is we have to be able to figure out and label our triangles so that we can actually see which sides are matching. Okay, so we can check for proportions. Okay, so we're going to name the similar triangles here. So the first thing I do is I take a look at my triangles and I need to label them. And some people will label them by side, so side DE. But I think when we first start, there's a little bit of an easier way to do this, and that is I call the sides large, medium, and small, and then I match them up to the other triangle, large, medium, and small. And I'm just going to show you what I mean by that. Okay, I'm sorry, my assistant is barking and yawning in the background. Okay, so in this triangle here, I think we can all agree that this would be the largest side. This side here is the medium, and then this over here would be considered the small side. So now I'm looking over here. My measurements are 2 4/10, 3 2/10, and 2 centimeters. So this is obviously the largest side. This is the medium side, and this is the small side. Okay, and so now what we're going to do is we're going to find out if those sides are proportional. Okay, so what we need to do is we need to set these up as ratios and check for scale factor. And if all of the sides have exactly the same scale factor, then we know that these triangles are similar. Okay, so I've now gone back to this method just because some people will use this. So we're looking at FD. So if we look at FD here, okay, you can see FD is the smallest side. So we would be comparing it to XY, and that's what I've set up here. Okay, so we have 3 centimeters divided by 2 centimeters, and when I work that out, I get 1 5/10. And let's remember we have no units, right? Scale factor is just a number. Okay, so that was our small sides. And that's how I would have set it up. I would have said small over small. And then we're going to do EF, which is our medium sides. So I would have put medium over medium, so 3 6/10 over 2 4/10. And when you take a calculator, you get 1 5/10 as your scale factor. You can't stop, okay? You have to continue. So now we're going to be checking DE as compared to ZX, which is our large sides. And we have 4 8/10 divided by 3 2/10, and we get 1 5/10. And so you can see that all the scale factors are exactly the same. And that means that these triangles are similar, okay? And now if we were going to compare and tell me if you were going to name the triangles that are similar, you have to name them by the same vertices, okay? So a way to do this is to set them up so that you are looking at where the longest and shortest sides meet, okay? So here's the longest and the shortest, which is D. So you write down D, and the longest and shortest meet at X, and you set that up beside it. And then where the two longer sides meet, okay, so the large and the medium, the large and the medium, so that's E and Z, and you write those side by each. And then when the two shorter sides meet, so that's the small and the medium, which would be F, and the small and the medium, which would be Y. And then you just write down your triangles just like this. Triangle D, E, F, and then you use this similar sign, okay, is similar to X, Z, Y, because those have to be in a specific order, okay, and we'll talk a little bit more about that. Okay, so that's your first example. So now we're going to check one here, okay? So in each diagram, name the two similar triangles. Two angles in each triangle are given. The measure of the third of each triangle is, well, we know that we can do the gazintas because they all have to add up to 180. So you can take 68 and 36 and add those together and get 104, and therefore 180 subtract 104, I'm going to do this the old-fashioned way, is 76. Okay, so that means angle A is 76 and angle P is also 76. So angle A equals 76 and it matches angle P. Okay, and then we have angle B, which is 68 degrees, and it matches angle Q. And then we have angle C, which is 36 degrees, and it matches angle R. And just like before now, okay, so the matching angles are equal, and so the triangles are indeed similar. To name the matching triangles, remember how we can do this? We can say triangle ABC, okay, is similar. That's the symbol we use to triangle PQR, because you set them up in the right order. Okay, so now we're going to find out if the matching sides are proportional. And second question here, and then we're going to stop the video because we're already at 8 minutes. So remember what I said. Quick, easy thing to do, because they're not sitting in a nice way that you can visually see that they're exactly the same. But it said here, we're going to check and see that by checking proportions. So here we have the largest side. This would be the medium side. This would be the smallest side. If I go over here, largest side, medium size, smallest side. So now we're going to set them up. The length of, and I'm going to do the large ones first, okay, and I'm going to call them, okay, DF is the same as LJ. Okay, so now I'm going to take that measurement and I'm going to go 5 4/10 is divided by 2 7/10. Okay, and then I'm going to set up the medium sides, and the medium sides are DE and LK. Okay, so if I set those ones up, that's 3 2/10 over 1 6/10. The length of the small side now, EF and JK, which is 2 8/10 over 1 4/10. Okay, so here what we're going to do now is you're going to take your calculator and you're going to divide this out. 5 4/10 divided by 2 7/10 is 2. 3 2/10 divided by 1 6/10, 2. 2 8/10 divided by 1 4/10, 2. So you can see all the scale factors are exactly the same, so these are similar. Okay, all the scale factors are equal, so the triangles are similar. The two longer sides meet at, so here we go, D and L. The two shorter sides, that's our medium and smalls, meet at E, K. And the longest and shortest side meet at F and J, and therefore DEF is similar to triangle LKJ.